Right. All right. What up, everybody? This is Mr. Stan coming at you with another physics video. This time we are talking about concave lenses. A concave lens looks like this, right? It's a lens which is thick at the top and at the bottom, but it is skinnier in the sides, right? And here to help us see what a convex lens does to light and to images is Sir Cockroach, and he is standing past the 2 times focal length over here. So, there are 3 different rays that are commonly used with concave lenses to kind of see what is going on with the object and image. First one is a ray that is parallel to the axis. And that type of ray is important because when that type of ray hits the lens, it is bent so that it goes directly away from the focal point on the object side. So you would draw a dotted line between where the ray hits the lens and that focal point. And then you just continue that line. Oops, sorry. You just continue that line up here into the up and to the right here, and that is what the actual ray of light, the real ray, is going to do. Ray number 2 goes through the very center of the lens, and when it goes through the center of the lens, it's not going to be bent up or down. All right, the overall effect of it going through the lens is that it's going to keep on its same course. And then the third type that's easy to draw is the one that is going from the top of the object directly towards the focal point on the other side of the lens. All right, so you can just imagine if this lens was not in the way, this straight line would land right here on the other focal point. When a ray of light is headed in that direction, it is bent by the lens so that it is parallel on the other side, parallel to the axis. All right, so let's review. First one starts parallel, ends going directly away from the focal point. Second one goes straight through the center of the lens without bending. The third one goes towards the focal point on the other side, but is bent so that it travels um, parallel to the axis. So, if we could have 2 of these rays converge across at some point, that would tell us where we would see the image. So we'll start with the first one. Okay, a ray of light would leave its head, go to the lens, and it would be um, refracted so that it's going directly away from the focal point. But if someone's eye was right here, it would appear to them like this ray of light was coming from down here somewhere, right? Since your brain will see the unbent ray. Then the second ray that we'll use is one that goes just directly through the center of the lens. And you can see that these have crossed right here, right? And so that's where the top of the image would be. Now, this is obviously an upright and smaller image, and it's a virtual image, all right? So I know one of these rays of light is real, the other one's virtual. We'll go ahead but if that's the case, unless they're all real rays of light, we call it a virtual image. All right, now let's move him closer. So now he is on the right side of the focal point, and sometimes with some lenses and mirrors, that changes what it looks like, but let's see what it does with the concave lens. So we'll start with ray number 1. Okay, parallel at first, and then it's bent, so it's going directly away from this focal point. And then ray number 2 goes from the top of top of the object through the center of the lens. And you can see that they cross right here. And so this is also an upright, smaller, and virtual image. So basically what's happened is as we've moved him closer, the image has gotten closer as well, and the image has gotten taller, but it will never get to be the same size as the object. Okay, so a convex lens will always show the image to be smaller and closer than the object really is. Okay, so that's all for this video. I'll see you all next time.